Hi class, welcome to lesson 2.7. Today's warm-ups we're going to simplify and state the restrictions. For A part I made up an example, and then for B part it's one of your homework questions from last day. So taking a look at example A, ladies and gentlemen, place all your factors in the expressions given. If you need again to use a margin to do your factoring on the side, please feel free to do so. Once you have all your factors listed, we look to cancel. Take a look here, ladies and gentlemen. We notice that it's easy to cancel. X plus 2 is the same as 2 plus x because both signs are positive. Also, please note that you can cancel out x minus 5 with x minus 5. What we're left with is 3x times 2 minus x divided by x minus 2. Please be careful with these two. I know many people like to cancel them right away. They look the same, however, their signs are opposite. So what we need to do, folks, is to realize that how can we change the signs? Basically, we're going to common factor out a negative 1. So what I see in the side margin here is I'm taking 2x minus, 2 minus x, and I'm going to common factor out a negative 1. And when you common factor out a negative 1, you change the signs. So it becomes negative 2 plus x or x minus 2. Once you've changed that, notice we have the negative out front, and now you can simply cross those out. So to simplify that, again, make note that if your brackets or your binomials have the opposite signs, simply common factor out a negative 1. Now your final solution simplified is negative 3x. Looking for your restrictions, ladies and gentlemen, you have x cannot equal negative 2, 2, or 5. Okay, taking a look at example B, ladies and gentlemen. It was from last day's homework, and we're dealing with a velocity question. If you take physics, ladies and gentlemen, grade 11 or 12, you'll be familiar with this formula. It's velocity equals mass over density. Please don't get caught up. It does look like a P. You can treat it like a P. And the density formula, it's just a Greek symbol that they use for density. Okay, so one way to rewrite this expression is you sub in the mass that's given, you sub in the density. Again, you need to do some factoring here, specifically on the second fraction. Before you do your factoring, though, ladies and gentlemen, remember that when you have a division sign, you've got to flip and invert your fractions. Okay, so noticing that on the original the original numerator, it's a difference of squares. It's now the denominator. So it's p plus 1 and p minus 1. Looking at the original denominator, which is now the numerator, it is a perfect square. So I take the square root of the first, square root of the last, and check to see if it's double the product in the middle. And it definitely is. So it's a perfect square. Otherwise, ladies and gentlemen, if you just use a side margin and do decomposition, you will arrive at the same solution. Okay? Again, just decomposition takes a little more time if you can't recognize those perfect squares right away. Looking to cancel, ladies and gentlemen, we've got p plus 1 and p plus 1. And we've got 3p plus 1 and a 3p plus 1 gets rid of that squared over there. So we're left with our volume formula of 3p plus 1 divided by p minus 1. So our restrictions, ladies and gentlemen, are that p cannot equal negative 1, it cannot equal negative 1/3, and it cannot equal 1. If you're wondering about where the negative 1/3 came from, remember 3p plus 1 cannot equal 0, so you solve for p, and p cannot equal negative 1. All right, today's lesson, ladies and gentlemen, is on adding and subtracting rational expressions. So when adding rational expressions, just like we did with fractions, folks, we need a common denominator, and we call that the LCD. So we're going to start off with having lowest common denominators that are numerical, but eventually we are going to have our LCD be products of all factors in the denominator. Okay, so taking a look at this first example, it says to add or subtract as indicated. So you look at your denominators, you've got 6 and 3. What number goes into both 6 and 3? 6. So your lowest common denominator is going to equal 6. You may choose on your second line, ladies and gentlemen, to, instead of just leaving the 6's independently, you could join them too as well. Okay, so this is another example. I'll show you how you could do your second line. Looking at our first fraction, ladies and gentlemen, 6 is already the common denominator, so that means that the numerator stays the same. So I'm going to write x plus 3. Then taking a look at our second fraction or second rational expression here, what has happened from 3 to get it to our lowest common denominator of 6? You had to multiply it by 2. Whatever you do to the bottom, you have to do the same to the top. So it's going to be plus 2 times whatever your numerator is. Okay? And then what you need to do for the next line, which brings down here, is you use your distributive law. So you multiply through your 2 into your bracket, and then simply collect like terms. All right, hopefully that example is self-explanatory for you. Come see me if you need some help. Getting a little bit more difficult here, ladies and gentlemen, is example B. Please notice that now we have variables. So whenever we have variables in the denominator, we are going to have restrictions. So looking at your LCD, that's where you look to see what your restrictions are. So if we asked you for your restrictions, it would be x cannot equal 0. So our lowest common denominator is 3x cubed because sorry, my fault, 6x cubed because 6x cubed can go in and 2x can go in to that evenly. All right, so what we need to do is we're going to make our denominator be 6x cubed. Then we have to decide, hey, if we have 6x cubed as our common denominator and our original denominator is just 2x, what value did we have to multiply the denominator by to get the numerator? So let's cancel out. 2 goes into 2 once, 2 goes into 6 3 times, and then when you use your exponent laws, you know that it's going to be x squared. So you're actually going to multiply by 3x squared to arrive at a common denominator. So again, that's where your 3x squared comes from, and you multiply it by the original numerator. Looking at the denominator, it has not changed. So to get from 6x cubed to 6x cubed, it stays the same. So if the bottom stays the same, so does the top. Then, ladies and gentlemen, all you need to use your distributive law. So you multiply through, collect like terms. And in this case, you can't collect like terms. But what we need to know, if they asked you for your restriction, x cannot equal 0. All right, moving on a little harder. Now we're going to see some factors here. This is a question that's going to take the entire page, and please try doing this with us, okay, ladies and gentlemen? All right, so looking at our lowest common denominator, currently we've got one that's got a factor of m, one that has a factor of m plus 1, and one that has a factor of m minus 1. And as I wrote up earlier, the LCD is going to be the product. So let's go up here for a second, guys. It's going to be products of all factors in the denominator. Unless they're repeated, you're going to include everyone. So when I scroll back down, the lowest common denominator here, folks, is going to be m times m plus 1 times m minus 3. And again, if you're asked for your restrictions, m cannot equal 0, m cannot equal -1, and m cannot equal 3. So again, the LCD shows you where your restrictions are. Now the hard part, ladies and gentlemen, is taking a look at how we get these to be equivalent. So ladies and gentlemen, looking at our denominator, from the first expression, we already had m that existed, so that factor exists as it is. But what other two factors need to be multiplied by? The m plus 1 and the m minus 3, which you will see right here. Okay, moving on to the second term. What currently exists in the second term? Let me just erase that. So in the second term, we currently have m plus 1. So what other factors do we need to multiply both the numerator and denominator by? It's going to be m times m plus 3, which you'll see right here. All right. And for the third term, ladies and gentlemen, what already exists as our denominator? It was m minus 3. So what two factors do we need to multiply both the top and the bottom by? That's m times m plus 1 right here. Yes, I know this is a long example. And so just be prepared on your unit test that this will be worth a lot more marks, okay? So we've got our expression done now. We're not out of the woods yet. We have to now simplify it. So in many times we're going to have to expand some of these brackets and then hopefully collect like terms when we are done. So taking a look, ladies and gentlemen, at the first one, I'm going to use FOIL. First, outside, inside, last. Now you're going to notice that I only have 3 terms here. What I want you to try to do, and you can use a separate sheet of paper or a side margin if you need to, usually when you do the outside and the inside, you then eventually collect like terms. So try doing that again together on the same step. So first of all, we go m times m is m squared. Now watch the second one. I'll change the color to red here. M times negative 3 is negative 3m, but then you do your inside, which is plus m. So what's negative 3m plus m is negative 2m. So we're just combining that just to save room, ladies and gentlemen. You don't want to be writing this this expression out as many times as need be. You want to minimize it because, again, look how long it is and how much time it takes. So try to practice doing your FOIL and combining the outside and the inside terms together. It doesn't always occur, but in many cases it does. Okay? And again, do your last, which is 1 times negative 3 is negative 3. Okay? Looking at the second part here, ladies and gentlemen, you could do this one of 2 ways. You could take the red brackets and multiply this through and then multiply in here. Or you could do the FOIL first, which means you're going to multiply the 2 binomials first and then times it by the m after. Just remember, it doesn't matter what order you do that in, but just remember that it's all multiplied by a negative 1 out front, which we will eventually have to take into consideration, okay? All right, and looking at the last example, again, you can choose to multiply both binomials first, or you could take a look at combining a monomial by the binomial. So in my case, I took the 2 binomials and multiplied them together, and hopefully you recognize them as a difference of squares when you combine them together. All right, once we've done our second line, then basically we're using our distributive law to get our third line. So the first term is impacted by a 2, the second term is impacted by a negative m, and the third term is just impacted by an m. So multiply those through. And then once you've removed all your brackets, then you can collect like terms. And again, if we asked you for your restrictions, m cannot be negative 1, 0, or 3. Any questions there, folks? I have one more example for you. So hopefully if you understand this, the only other thing we have to add in is the factoring component. And this is where you get to your level 4 stuff, might be an inquiry or a hard application question on your test. So let's take a look at D, and I promise you this is the last question we're going to do for today's lesson. I would encourage you to try this on a separate sheet of paper with me if you're not already doing so. Looking at D, notice that our denominators aren't factors as they are trinomials. So we need to actually factor them to get them into products. So then once we have products, then we can find a lowest common denominator. Again, these aren't products, so we can't do anything with them right yet. Have to get them by themselves into products. So on a separate sheet of paper, or maybe you can just do this as is with your simple factoring, simple trinomial factoring. Okay, so x squared plus a squared plus 5a minus 6. Your 2 factors are a plus 6 and a minus 1. Please make sure, folks, when you're dealing with 6's that you don't think it's a b. I've had several students think that 6's turn to b's, and then they get really confused in their work. Okay, so make special note of that. When you go to factor your second denominator, a squared plus 3a plus 2. Again, it's simple trinomial factoring. You should have a plus 2 times a minus 1. Look now, ladies and gentlemen, now that they're all products, now we're going to decide our LCD. And since none of them repeat, we've got to write all 4 of them down. Okay, so all 4 of them become your LCD. Let's look at the first expression now. How do we make this equivalent? Currently, the a already exists, but below a, we've got 2 factors. So we already have a plus 6 and a minus 1. So the other two factors that need to be multiplied to make it equivalent are a plus 2 times a plus 1. Looking at our second expression, currently in the denominator we have a plus 2 and a plus 1. So we've got 2 of the 4. We need the other 2, which is a plus 6 and a minus 1. Once you've got that, ladies and gentlemen, then it's just a matter of doing your expanding and collecting like terms. So again, you do your FOIL first. Try to do that first, outside, inside last, and do the outside and inside together. So I'll help you with that again. A times a is a squared. That's a squared. And then a times 1 is 1a. Do the inside. It's 2a. So 1a plus 2a is 3a. Okay, and 2 times 1 is plus 2. Again, we can try that again in our second example here. A times a is a squared. A times negative 1 is negative a. And 6 times a is 6a. So 6a minus 1a is 5a. And then 6 times negative 1 is negative 6. A common mistake I find here, and I'm not sure why, is people when they go 2 times negative 1, sometimes they write plus 3. They actually add it instead of multiply. So make sure you didn't do that in your example. All right. Once you have your you've done your FOIL, then you just simply use your distributive law, multiply through, and collect like terms. All right, ladies and gentlemen, here ends this lesson on 2.7, adding and subtracting. I just want to make note, ladies and gentlemen, that on the next page over, so I'll just flip the next page over. This is one of the hard questions from last night's homework. You might want to check it out. So this was number 13. And yes, it was a doozy. It takes a while. Okay, so it asks you to simplify that out and then to state your restrictions. And can you believe it? There's 7 restrictions. So I'll leave that there for you to go through. Okay. I don't think I'd be able to give you something this hard on the test because it might take you half the test, but something with at least 2 of these expressions I would expect you to do, but maybe not 3. Okay? All right, so give that a try. Okay? Or take a look at that, see if you can get that, folks. And then I want to also, I apologize, I want to go back and show you your homework questions. So your homework again tonight is page 128, numbers 5A and B, 6A and B, 7 to 9, and try challenge number 12. Have a great day, guys.